A linear function is a function whose graph is a straight line. Its algebraic form is as follows: y equals mx plus b. X and y are the variables. X is the independent variable, and y is the dependent variable. M and B are not variables, they are numbers. M is a number that is called slope. And B is a number that is called the y-intercept. Now we are going to learn the meaning of M and B. Let's draw coordinate axes. Let's scale the axis for X, and now let's scale the y-axis. So those are our coordinate axes. As I said, M and B are numbers, not variables. So for each function, those would be definite numbers. We are gonna state a definite number for M and a definite number for B, and we will see which graph comes up. Let's say that M is the number 1. And let's say that B is the number 2. So we have our function now. Y equals 1 times x plus 2. Actually, when 1 is the number multiplying the x, we can avoid writing the number 1. But we are going to keep it. And here's our graph. This is the line represented by this function. This is the algebraic form of the function, and this is the graph of that function. As we can expect, being a linear function, it is a straight line. And we can see now the meaning of M and B. B, being the y-intercept 2, corresponds with the point in which the line hits the y-axis. So the y-axis is intercepted in 2, corresponding with B, the y-intercept. And 1 is the slope. The slope is a measure of how steep the line is. What we are going to do now to see the meaning of the slope clearly is change this number, change the slope. Let's say that we are going to change the slope just a little bit. Instead of 1, it will be 1.1, and let's see what happens. And here we go. Here we can see how the line has changed its slope. It is now a little bit steeper. a little bit steeper. Let's increase the slope a little bit more. Let's say that now the slope is gonna be 1.5. Let's see what happens. Here we go. So now we see again that the slope is even steeper, 1.5. The y-intercept is still 2. We haven't changed that, so the y-intercept is still the same number. Let's change the slope again. Let's make it 2. Instead of 1.5, we're gonna make it 2 and see what happens. So it happens exactly what we expected, that the line became even steeper. This is the line, okay? And now let's go back to our original line. Let's make again slope 1. Well, as I said, number 1 is not necessary to write it, so we're gonna just avoid writing number 1 and see what happens. That's our original line. Okay, and back in our original line, we are gonna decrease the slope now. So instead of 1, remember that there's 1 here, though we don't write it, we're gonna make it 0.9. We still keep the y-intercept. Let's see what happens. And here we go. We can see how the line is less steep now. A little bit less steep. We're gonna change again the slope. Let's make it 0.5. And what can we see now? We see that the slope is lower, so the line is less steep, even less steep. Let's decrease the slope even further here, and we see how the slope becomes lower and lower and the line becomes less and less steep. Can anyone guess what is going to happen if we make the slope 0? Obviously, if we make the slope 0, 0 times x, whatever x is, will disappear, will vanish. So we would have only y equals plus 2. Y equals 2. What does it mean? Exactly. Slope 0 means a flat line, horizontal line. This is a constant function. Constant function. It is a flat line. Slope 0. But we can make slope even lower. Don't forget negative numbers. So we're gonna make slope lower than 0. That is negative 0.2 x. Now x appears again. It's not 0, the slope. Let's see what happens. Right, now the line is becoming steeper again, but in the opposite direction. Before it was a line that was going up. Now it is a line that goes down. It is a decreasing function. When the slope is negative, we have a decreasing function. This is not constant anymore. Decreasing function. When the slope was positive, it was a an increasing function. This is a decreasing function. Let's go on. In all this time, we have kept the y-intercept. Number 2, it's not negative 2, sorry. Number 2 is still there. So it's still hitting the y-axis in number 2. Let's decrease the slope even further. Let's make it negative 1. Remember that number 1 does not is never written, so we can avoid it. So the function becomes y equals negative x plus 2, and the graph is like this. Let's go back to our original line. Here is our original line, so let's remove a negative sign, again a positive slope, and now we are gonna change the y-intercept and see what happens. This is easier than the analysis we have done before. So let's make this 2. Let's make it 3. So what is gonna happen? Right, now the y-intercept is 3. That means that the line hits the y-axis in number 3 instead of 2. Let's make it 1 and see what happens. Right, now our line keeps the slope. The slope is 1, the same as it was before, as our original line, but the y-intercept now is 1. Okay, let's make it 0. Let's make the y-intercept 0. What do you think it would happen? Right, the line goes now through the origin. This is what we call a proportion function. Proportion function. So proportion functions are of the type y equals m times x. M times x. B is not there because we have made it 0. So y equals mx is a proportion function. In this case is the identity because m is 1, but it could be different. We can change the m and the line becomes steeper or less steep. Now let's go on, let's make b a negative number. So we have to change this plus sign into a minus sign. Minus 1, it won't be a proportion anymore. And how would it be? That's it. So we can see it keeps the slope is 1, but now it goes through negative 1. So the y-intercept is negative 1. So that's how the slope and the y-intercept change a function, the graph of a function.